All right, senior math, welcome back. Today we are talking about variability and standard deviation. So this is going to be our first thing we're going to jump into in this new unit with statistics. So variability is an important characteristic in data, and essentially it represents how widely spread or how ranged is your data. So, for example, if you were measuring manufacturing bolts, the extreme variation in the bolt's diameter would cause for a large number of defects. If you have a lot of manufacturing bolts that you need created, and you're getting a lot of bolts that are wider than what is needed, you're going to have some loose screws or loose bolts or whatever, and you're going to have a lot of defects. So the more variability that occurs with these manufacturing bolts could cause for a lot of problems. On the other hand, if you're trying to discriminate between good and poor accountants, you would have a hard time if the test grades all produce a little variability. If all of the accountants show the same scores or very close scores, it's going to be a hard time determining which one's better and which one's not because all their scores are very similar. So little variability makes it hard to discriminate while a large variability can cause for lots of issues. So variability is a good way to get a mental picture of the spread of data, how widely spread something is, or are you getting a lot of numbers all over the place, or are you getting a lot of numbers very close together? Variability is a good way of testing that. Now, range is one of the most simplest ways of measuring variability. So to find the range of data, all we have to do is we have to take the difference between the largest number and the smallest number. So we're going to look at the data set. We're going to look at what's the large number, what's the smallest number, and we're going to subtract them. So in this example here, my largest number is 14. My smallest number is 8. No, sorry, my smallest number is 5. So I'm just going to do 14 minus 5, and that's going to give me a range of 9. So I know from my largest number to my smallest number is 9. Now that's good and all, but it's not the most effective way of measuring data because it tells me my range is 9, but it doesn't tell me how widely spread that data is within that range. And if we have an outlier, we might have a huge number that's going to throw off that data as well. And if we look at these two histograms right here, let me move this up here. Look at these two histograms. They both have the same range. They both have the same spread. But if we look at the data, their variability is much different. My first graph, the majority of my points are in the center. I have a large majority of data in this center area. So that's going to be my mean is going to be in here. So the majority of my points are going to be close to that mean. I don't have very many points far away from that. While on the other hand, this data set, I have a lot of points that are away from my mean. My mean's still going to be in that center because it's going to average out to being in that middle, but I have a lot of points on each end, making the variability much wider. I have a much higher chance of getting a number much lower or much larger than my mean. I don't have a very good chance of getting a number that's close to my mean. So having B as a histogram is going to show you have a lot of variability, while A shows that we have limited variability. You do have some spread, but it's not as much as what you're mostly common going to get something in the middle. And so having just the range can't really tell us how much variability it has. It just tells us sort of what is the difference we have. So we're going to talk about something called standard deviation. Standard deviation is a great way of showing variability. And it's a much more effective method. So let's start off with the sample data. So we have 5, 7, 1, 2, and 4. These are going to be my sample points. So I'm going to plot this data, and I'm going to look at what is the average of this data. So I have 5 right here. I plot my point. 7, 1's way down here, then 2, and 4. So these are my points. If I find the average of these, we know the average is adding all the numbers together and dividing by however many numbers there are. So 5 plus 7 plus 1 plus 2 plus 4, all divided by, I have 5 points. If I add all of those together, that's 19 divided by 5 gives me 3.8. So my average point is 3.8, which is kind of like right about here. That's my mean. Now, remember, we typically represent the mean with this funny little U symbol. That's the Greek letter mu. It's like a U with a tail in front of it. So whenever you see that symbol, that means average or the mean. So that's our mean of our data set. Now, if we look at these data points in comparison to our mean. The distance between each measurement and the mean will help you measure the variability. So if the distances are large, the data is going to be more spread out and more variable. If the distances are small, that means our points are very close together and we have smaller variability. And we call these distances deviations. So we can look what is the deviation between each of these values and our mean. So for example, I could take 1 and I could find what's the distance between 1 and 3.8. What's the distance from 2 and 3.8? What's the distance from 4 and 3.8? So that's going to have a small variability, while 7 is going to have a much larger variability or a much larger deviation. Now, one way of testing variability is because we have these 5 different deviations from our mean to our measurements, one way to combine these into one number to show variability is to average them all together. So we can find the average deviations or the standard deviations of all of those. And then that's a good way of showing variability. It's a good way of showing how spread our data is. Are we going to is it common to have a large variability? Is it common to have a small variability? So that average is a very important number that's going to help us, and we can use it for a lot of things in statistics, especially in the future. This is something we're going to use all throughout pretty much the rest of statistics. We're going to have standard deviation show back up. But because some of the numbers may be negative when we take the difference between them, like if we do 3.1 minus 1, or sorry, if we do 1 minus 3.8, we're going to get a negative number. So because some of the numbers might come into negative, we're going to have to square some of these numbers. So what we're going to do is we're going to take each of those data points, we're going to subtract our mean from that data point, and then we're going to square that value. And the reason we're squaring it is so we don't have any negative numbers when we're left over with. So for example, I'm going to do 5 minus 3.8, and that's going to give me 1.2. And then I'm going to take 1.2 and I'm going to square it. So 1.2 squared equals 1.44. Then I'm going to do the next thing with my next data point. So 7 minus 3.8. I'm subtracting that mean once again that I found. That gives me 3.2. Then I'm going to take 3.2. I'm going to square that value, and that gives me 10.24. I'm going to do this with each of my points. So 1 minus 3.8 gives me negative 2.8. So this is why we have to have the square value, because negative 2.8 squared is going to give me a positive number. It's going to give me 7.84. I want all my answers to be positive so they don't cancel each other out. 2 minus 3.8 is negative 1.8. And then once again, I'm going to have to take negative 1.8 squared. Put it in parentheses so I make sure it turns into a positive, which is 3.24. And I have a last number of 4 minus 3.8, which is only going to give us a value of 0.2. If I do 0.2 squared, that gives me 0.04. So I now have the deviations of all my points, and I have the positive squared values of all these deviations. Now, our goal is to find the standard deviation. So that means the average of all these deviations. So I want to find the mean of the differences between my means. So what I need to do in order to find the mean, once again, every time we find the mean, we add up all our numbers and we divide by however many numbers there are. So I need to add all these numbers up together. I'm going to add all these values, these squared values I just got, and that's going to help me find my standard deviation. So if I do 4.1 10.29 plus 7.84 plus 3.24 plus 0.04, all that adds together to be 22.8. So this funny little symbol right here, this is the Greek letter sigma. We use the Greek letter sigma in mathematics to show adding things together. So whenever you see that, it means add all those terms together. So this means take a data point, minus your mean, square it, and add them all together. Gives us 22.8 is what that phrase is saying. So the next step to find the average of a deviation is divide by the number of measures that we have in that data set. In this case is 5. So once again, whenever we average something, we add them all together and divide by however many numbers there are. So 22.80 divided by 5 gives me 4.56. This is the number we call the variance. And it's represented by this little symbol down here. This is the Greek letter sigma. We use a lot of Greek letters in statistics because we have a lot of different things that we have to measure. So that's sigma squared. Now the thing is, we don't want sigma squared. We want the standard deviation. So this isn't the number we're actually looking for. This is the square of the number that we're looking for. So it's the square of our deviation. So in order to find the correct average, the last step we need to take when finding the standard deviation is to square root this number. So we're going to square root 4.56, and that's going to give us 2.14. And this is our standard deviation. This is our important number. We typically represent this number with just the value sigma, the single sigma. It's like a circle with a little line coming off the top of it, or a circle with a hat. So this number is the standard deviation, and it is the average of all your deviations of your data set. So once again, this is a very important number that we're going to use a lot throughout statistics. Anytime we have to find averages or find average distances or variability of things, we're going to use standard deviation. We're going to keep coming back to this. It's a very good way of testing or showing, okay, is there a lot of variability in this data set? Is there a lot of differences, or is this data set very similar? And so standard deviation is a big part. So let's break that down. We did a lot of things. Let's break that down into some more simpler steps to help us remember how to do this. So if we look at the formula, this is your formula for standard deviation. It's a lot. It's a big crazy mess. Well, let's break it down into what it means. So step number one that we did was we found the mean. So step number one is find the mean of your data set. Step number two, we had to subtract each value from the mean. My pen will write today. Subtract mean from each number. So once we found the mean, we had that big chart where we were subtracting things. So step number two that you have to do is you have to subtract the mean from each data point. That is going to be your second step that we have to perform. Step number three is this little guy right here. It's that squared symbol. So step number three is we are always going to square the results. That's always going to be our third step. Step number four, once we squared all those results, we added them together with that big sigma symbol. So we have to, once you square all those numbers, we're going to add them together. Step number five, when we added them together, we have to divide. So we'll remember adding together, then dividing by the numbers that we have. That's our way of finding the average. So step number five was divide by the number of points that we had. Anytime you find the average, we always have to divide. And then last step, 6, is we have to take the square root. Because remember, we squared the numbers earlier, so we have to square root to get rid of it. So these are your 6 steps we have to do in order to find the mean, or in order to find the standard deviation. Yeah, step number 1, find the mean of your points. Step number 2, subtract the mean from each of the data points. Then square those results, add them all together, divide by the number of data points you have, and then square root that final answer, and that is your standard deviation. So once again, this is a big important thing that we're going to use a lot in the future, so it's important for us to be able to find this. So let's look at an example. Let's do one example together. And let's just like work through it just to see how this actually works through. So once again, step number 1, I need to find my mean. So my mean of my data points, looking at my points are 1, 1, 2, 3, 5. So my mean, my mu is going to be 1 plus 2 plus 3 plus 5. All my points added together, then divided by the number of points there are, which is 5. So that gives me 12 if I add them all together, divided by 5 gives me 2.4. So that is my mean. Step number 2, we had to subtract the mean from each of our values. So I'm going to take each of my values and I'm going to subtract 2.4 from it. So 1 minus 2.4 gives me negative 1.4. Well, my second point is also 1, so that's going to give me the same answer. 2 minus 2.4 gives me negative 0.4. 3 minus 2.4 gives me 0.6. And then 5, my last term, minus 2.4, gives me 2.6. All right, so that's my second step where I subtracted. Step number 3, we had to square each of those results. So I'm going to square each of these results. Negative 1.4 squared gives me 1.96. Negative 1 squared is the same thing. This is going to be 1.96. If I square negative 4, that's going to give me 0.16. Once again, all these numbers should be positive because we're squaring them. Because a negative times a negative is always going to give me a positive. That should be a 6 right here. 0.6 squared is 0.36. And then 2.6 squared is 6.76. All right, so I squared all my numbers. Step number 4 was we had to add all of them together. So I had to add all these guys together, which is going to give me 11.2. I add them all together, got 11.2. Step number 5, we had to divide by the number of points we had. So we have 5 points once again, 1, 2, 3, 4, 5. So we're going to take 11.2 divided by 5, and that gives me 2.24. And the very last step we have to do is square root. So if I take the square root of 2.24, my answer is 1.50. And this is, once again, this is my sigma. My standard deviation is 1.50. So that is my solution. So what this means is that the average distance from each of my data points to that mean is going to be 1.5, which means all my points are fairly close or within 1.5 distance to my mean on an average distance, which means my points are going to be fairly close together. 1.5 isn't a large deviation. It's not a big standard deviation. And so because I have a fairly small deviation, that means it's not going to be a huge spread of data. So that's where we're going to pause for today. You're going to have a little bit of practice over this. We're going to do a little bit of fun typing activity where we're going to find who's the better typer. Is it the women in the group or is it the men in the group? And that is going to be our next activity we're going to jump into. Oh, wrong button.